So that's what we're doing here. I also did put a picture of this in the slides in case, for some reason I wasn't able to graph it, but you saw I was able to. Something, maybe if Desmos didn't work or something, I don't know. But, just to be on the safe side. So let me get to that. Here we go. All right. So let me get to that. Let me go back to the slides. There we go. There we go. Like so. So I did put the picture here as well. And again, you can see it's the same thing. Okay. All right. That was an example. Now, are there any questions about that? Okay. So I figured it'd be good to let everyone try one, so you guys get some practice doing this. And let me just say this though also, that for the first equation, notice the denominators are 3, right? So if you want to clear the denominators, which I recommend you do, kind of like what I did, right? In the previous example, I multiplied by 7. Here, I would multiply by 3. And that will clear the denominators, okay? So I figured it'd be good to let everyone try this out for about, 5 minutes. So I'm going to stop the recording, and I'll wait about 4 or 5 minutes, and then we'll do it together, okay? Obviously, it's not to hand in, so, but I do like to let everyone try it out for a bit. So I'm going to stop the recording. So I'm recording. So for this one again, what we want to do is we want to, solve the equation, okay? We're going to solve this equation, okay? And what we're going to use is the method of elimination, okay? There's other methods, there's substitution, there is graphing, but again, because we're in this online digital world, I figured with graphing is something I wouldn't really focus on too much. So here, as I said, okay, what I would do first, you don't have to do this, but to make it a little bit easier, what I would do first is eliminate those denominators. And you could do that by multiplying both sides by 3. Okay. Okay. Good. Basically, we're doing like what we dealt with in section 1.1, right? We had an equation, although it was an equation in one variable, though, the idea is the same here. If you have fractions, you can eliminate them by multiplying both sides by the least common multiple of the denominators. But in this case, the denominators are the same, so you just multiply by the denominator itself. All right. Anyway, so when we do that, right, we're multiplying by 3. As you can see, I'm distributing, right? We have 3 times x, 3 times this, right? And we have 3 times 11 over 3. So we have 3 times x, as you can see, minus 3 times a third times y. But 3 times a third we know is 1. So we just get y here. Here, the 3's cancel, right? And we just get 11. So again, we multiply both sides by 3 because we want those denominators gone, right? Because now you can see we have this equation, and looking at this system, right? This one now looks a lot easier, doesn't it? Okay. If you had to solve this one or this one I would prefer to solve. Okay, cool. All right. So for this one, right, what can we do? Well, I mean, looking at the second equation, we could say, oh, well, we can eliminate x. We could just multiply by -3 and then add. But we don't have to do that, right? If I were to add these equations immediately, right, the y's would cancel. You can see that the coefficient of y here is, well, we're subtracting y, so it's -1. Here we have 1. So if we were to add these equations, the y's would cancel. And that's awesome. And that's what I'm doing here. Right? So we add these together. As you can see, we have the y's are gone. 3x plus x, that's 4x, right? So we have 4x plus 0 is 12. 4x plus 0 is 12. So 4x is 12. So what does x have to be? Well, that's pretty simple, right? We just divide by 4. We get 4x over 4 equals 12 over 4, which is equal to 3. So we get x equals 3. So our answer then is x equals 3. Good. Now, are we done? No, we're not, right? What about y? We can't forget y. Now, we can really use either equation to get y, okay? I'm going to use the second. You could use the first. I mean, you want to use either one of these two equations. You just replace x by the number you got in an equation, right? As I'm doing here. And then you get what? You could solve for y easily. Right? So I'm using this equation, even though really it doesn't matter which one you use. So I replace x by 3, and now we solve for y. So we subtract 3 from each side. We get y equals -2. So y equals -2. Okay? And so now our answer is 3, -2. So that's our only answer to the system, to our system of equations. That's our only answer. And yes, we should check by graphing, so I'm going to do that. I mean, you don't have to do that, but again, especially with this final coming up, I would recommend you do that. You know, it can't hurt. All right, so what I'm going to do now is I'm going to stop sharing this. I'm going to go to the Desmos. No, there it is. All right, here it comes. Let me get rid of these two. Okay, so now we have to type in the equations, right? All right, so wait, come back. There we go. So we have x minus 1 over 3 times y is, I think, 11 over 3. Right? I think that's what we said. Yep. And then for the second one, we have x plus y equals 1. So I'm typing in the equations, right? That's what I just did. I typed in the equations, okay? They're typed in. And now we look at the graph. And yes, we can see that, yeah, there's only one point of intersection. The two lines are going to intersect at only one point. So there's only one solution. And what is that point? Well, if we hover the mouse over it, we get 3, -2. That's what we got. That's what we got already. So our answer is right. So again, I just checked it using Desmos. Okay. Let me now, oh, any questions on this? Okay, let me get back to the notes. Okay. On the final, okay, if I tell you to use a method, you really want to use that method. But if I don't tell you what method to use, you can use either one. Okay? Although here, because we have graphing, and graphing technically is a method, I'll probably say to use either substitution or elimination. Also, I did put the graph in here, just to illustrate in case Desmos didn't work for whatever reason. But either way, we got 3, -2, and that's what matters. All right. So, well, before we get the trig though, are there any other questions at all? Okay. So again, what I want to do now is I want to do some reviewing. So what I want to do now is to start reviewing some trig. Again, I know the trig wasn't on the third test. So I figured it wouldn't hurt to go through it a bit. So I figured for the rest last week we review a bit. All right. I guess I was just so concerned about covering too much material, and then, people get overwhelmed, and if I go too fast, people don't learn much. So I just thought it'd be good to review stuff, just to bring up stuff that people tend to have trouble with. And trig, unfortunately, is one of those things. Okay, so here, remember, this is just the definition of sine, cosine, and tangent. This is just as a reminder. You have an angle theta here, which is acute, meaning it's between 0 and 90 degrees, right? Okay, the side opposite theta is called OPP, which is opposite. The side next to it is what we call ADJ, which is adjacent. Hype is hypotenuse. That's always opposite the 90-degree angle, okay? Always opposite it, as you can see. And then you have the definition of the trig functions. Again, we've seen this slide before, and you could always remember this using SOHCAHTOA, as you can see. Good. All right. Let me just get the recording. Let me just take care of the recording, because if it goes too much, then YouTube gives me heck for loading it. All right.